This is the podcast for electromagnetic waves and radiation. This is a new chapter, so you'll need a new title page for this one. Okay, the concept that we're going to learn about in this section, electromagnetic waves are transverse waves that can be produced by vibrating electric charges. You have two essential questions. Remember, your essential questions goes on the page after the title page. Number 1, how do electromagnetic waves transfer radiant energy to matter? Number 2, how do we know electromagnetic waves is a transverse wave and not a compressional wave? Remember, transverse waves move up and down. Compressional waves are the back and forth motion like a slinky. Waves in space. Electromagnetic waves are everywhere. Waves are produced by something that vibrates. Without matter to transfer energy, waves cannot move. So without matter, there's no vibration. Electromagnetic waves do not require matter to transfer energy. So they can transfer energy in space because in space it is a vacuum and there is no matter. Electromagnetic waves, we do not see them. However, they are always there. They're made by a vibrating source that can travel through space where matter is not present. Instead of transferring energy from place to place, the waves actually vibrate by transferring the energy between a vibrating electrical and a magnetic field. So we have a transverse wave that's moving one way that's made of an electric field, and then we have a magnetic wave that's moving perpendicular to that. So together they're working to form these electromagnetic waves. The energy transferred by these waves is called radiant energy. Radiant energy is what makes fire feel hot. It also enables us to see light. Moving electric charges are surrounded by an electric field and a magnetic field. So when we have these electricity charges moving, we have a field that's kind of engrossed around these waves. So it's not just powerful waves that are coming with the electromagnetic waves. It actually has like a force field that has been surrounding it. So if you look at this image, it can kind of illustrate what I was talking about. The electric field is going like up and down. The magnetic field is going back and forth. So these two fields are linked together. So this radiant energy that electromagnetic waves can carry, it can travel at the speed of light. Electromagnetic waves travel more slowly in matter with the speed that depends on the material. So in space, you're going to see that it's going to be traveling really fast, but once it gets into Earth's atmosphere, it's going to travel a little bit slower. Property of electromagnetic waves, again, it is a transverse wave, so it's going to have wavelengths, it's going to have frequency. Remember, frequency is the number of wavelengths that passes a certain point in 1 second. The frequency of an electromagnetic wave is also the number of vibrations of the charge in 1 second. So trying to think back to when we were talking about the transverse waves and the electromagnetic waves and the compressional waves, a wave is a disturbance that carries energy and particle is a piece of matter. So remember, wave does not carry matter, it carries energy. A particle is something that's in its way, a piece of matter. Albert Einstein explained electromagnetic waves can behave as a particle, so it can behave as a piece of matter. And he called these photons, which means that their energy depends on the frequency of waves. So essential question number 1, how do electromagnetic waves transfer radiant energy to matter? Well, electromagnetic waves can cause charged particles within the object to move. Essential question number 2, how do we know electromagnetic waves is a transverse wave and not a compressional wave? Well, the vibrating wave is perpendicular to the direction it travels, not back and forth. So we had the up and down motion of maybe the electric field, and then the magnetic field is perpendicular, and they are traveling opposite to the direction that they are moving. So that concludes the podcast for section 1 in electromagnetic waves.